You start digging straight down, and for the first few miles, it's just rock, slow and unremarkable. But somewhere far beneath your feet, this planet is hiding a place hotter than the surface of some stars, under pressure that would crush a submarine like a soda can. And humanity's deepest hole ever drilled barely scratches 0.1% of the way there. That's the real answer to today's question. What happens if you dig a hole through the entire Earth? Not a quick shortcut to the other side of the world. A journey through some of the most extreme conditions anywhere in the solar system, using nothing but a straight line and enough determination. This isn't just imagination. Starting in 1970, Soviet scientists actually attempted something close to this on the Kola Peninsula in the Arctic, drilling what became known as the Kola Superdeep Borehole. After nearly 2 decades of continuous effort, using specialized drill bits designed to survive extreme heat, they reached a depth of about 7.5 miles, deeper than any human-made hole before or since. And they had to stop, not because they ran out of ambition, but because the rock at that depth was already far hotter than anyone predicted, soft and unstable in ways that made further drilling essentially impossible with the technology of the time. Here's the one concept you need. Earth isn't a uniform ball of solid rock all the way down. It's built in layers, a thin crust we live on, a thick mantle of slow-flowing rock underneath, a liquid outer core of molten iron and nickel, and finally a solid inner core, crushed so intensely by pressure that it stays solid despite temperatures rivaling the surface of the sun. Each layer gets more extreme than the last, in both heat and pressure, the deeper you go. So let's walk through the actual journey, stage by stage. First, that 7.5-mile record from the Kola project already reached temperatures over 350 degrees Fahrenheit, hot enough that the rock stopped behaving like solid stone and started behaving more like thick plastic, deforming around the drill instead of staying open. And that's barely a scratch. Earth's radius is about 3,900 miles, meaning the deepest hole humans have ever drilled represents roughly 0.2% of the total distance to the center. Then, continuing down through the mantle, which makes up the vast majority of Earth's total volume, temperatures climb past 3,000 degrees Fahrenheit, and pressure builds to well over 1 million times what you feel at sea level. The mantle isn't liquid, despite the common myth. It's solid rock that flows unbelievably slowly, over millions of years, the same way glacier ice flows downhill without ever melting. But any drill reaching this depth would be instantly destroyed by heat and pressure that no material humans have ever built could withstand for more than a few seconds. Deeper still, you'd reach the outer core, roughly 1,700 miles down, where iron and nickel exist as liquid metal, churning slowly in currents that actually generate Earth's magnetic field, the same field we talked about back in the episode on Earth's rotation. At the very center, the inner core reaches temperatures around 10,000 degrees Fahrenheit, comparable to the surface of the sun itself, kept solid only because the pressure there, over 3 million times sea level pressure, is strong enough to force iron atoms into a solid state despite that extraordinary heat. Here's the twist that makes this stranger than pure heat and pressure. Gravity itself changes as you descend, and not the way most people assume. As you burrow deeper, more and more of Earth's mass ends up above and around you instead of purely beneath you, pulling in multiple directions at once and gradually canceling itself out. By the time you reached the very center, gravity from every direction would cancel out almost perfectly, leaving you essentially weightless, floating at the exact middle of the most crushing environment on the entire planet. A strange contradiction where the deepest, most extreme point on Earth is also the one point where you'd feel no weight at all. That's the edge of what we know. Theoretically, if you built a frictionless tunnel straight through a perfectly uniform Earth and jumped in, physics says you'd fall, accelerate, then decelerate symmetrically, and pop out the exact opposite side of the planet in about 42 minutes, a real calculation known as a gravity train. In practice, no material on Earth could survive the heat and pressure long enough to ever test it. So here's the honest answer. A hole through the entire Earth isn't blocked by any single wall or barrier you could engineer your way past. It's blocked by a continuous, escalating gradient of heat and pressure that gets measurably worse every single mile, until you reach conditions that genuinely rival the surface of a star. All happening directly beneath the ordinary ground you're standing on right now. Completely invisible and easy to forget about. There's a very different kind of extreme environment waiting in our next episode. One humans are actually trying to reach on purpose. What happens if humanity tried colonizing Mars tomorrow? That's a story for another episode in this series, so subscribe if you don't want to miss it. I'll see you at the edge.